This class is about paper 5 of Cambridge A2 chemistry. Here I'll discuss happening planning an experiment. In paper 5, there are two types of questions are coming. One is planning an experiment, another one analysis and evaluation. This class is about the planning an experiment. Total approximate 15 marks questions are coming. Only one question for the planning. Here mostly dependent variable, independent variable, and the safety precautions and some calculations are coming. Also, diagram can be come, but this question is about planning an experiment. How to plan an experiment? This is regarding how to find out the soul present in water. If you see, if you collect tubewell water, you can see there are some sediment after sometimes if you collect tubewell water and with sometimes you can see the reddish sediment. This sediment is called salt. This is the compound of iron trioxide. So this is not the clear solution, or this is not the precipitate. Between these two, the salt is between these two. I want to see you more information regarding salt. Salt is a type of colloid in with disperse phase in solid, and dispersion media is liquid. Its particle size ranging from 1 nanometer to 1 micrometer. Actually, this is a turbid, is not the clear solution or not the sediment actually. So I'm going the main point again. Here a salt contains insoluble but don't from a precipitate. This is between these two. A salt is harmful for the human body. So we want to remove the salt. Question is, we can use iron trichloride crystal to remove the salt. This is irritating to the skin. So safety precaution. What safety precaution is needed when you are handling uh, this chemical to remove the salt from the water? It can be wire gloves. Then particles of salt can be positively or negatively charged. Students use this experiment to set up shown to confirm that iron 3 oxide salt particles is positively charged. I want to see more positively charged salt. Here, positively charged salts, metallic hydroxide, iron 3 hydroxide, aluminum hydroxide. These are positively charged salt. There are also negatively charged salt as well, but salt can be positively or negatively. Here, the experiment is used in the laboratory to detect the or separate the salt from the drinkable water. So we are using here salt in the middle of the YouTube, and the two portion we are using distilled water. To see it is difference. When we turn on the electricity, the salt here, iron 3 salt are positively charged, so it will move towards the negative electrode. And the positive electrode, nothing. So if you see here, predict the color of the distilled water in the both sides of the YouTube after 30 minutes. After 30 minutes, if the iron 3 oxide salt is positively charged. Observe in the side in positively charged, it will be colorless, and the negatively charged salt, it will be red color. So I think clear to you. This is iron 3 oxide will move towards the negative electron. And salt solution can be added to salt can cause them to precipitate, and this method is used in water purification. So student, we are using the following salt. Just I'm giving one message to Nahid. Okay, okay. Just few minutes. And 100 cm cube of standard solution containing 0.1 mole per dm cube of falling ions. This solution can be used to detect the salt. So what mass of solid potassium sulfate? Potassium sulfate is here 1 mole, 0.1 mole per dm cube concentration, and 100 cm cube is the volume. So the we can find the moles first, volume into concentration. Then we know the MR of potassium sulfate. So 1.74 is the result. Describe how the student should have accurately prepared this solution of standard solution from potassium sulfate mass calculated in C1. Previous question we have calculated 1.74. We have to take in a beaker, and we can add Here we can add here few amount of water less than 100 cm cube, then dissolve it. We can transfer to the volumetric flask, and then the rest of the water we can fill up with the distilled water. And this is the solution. It's quite easy solution preparation. The similar method we have studied previously. Then the student carried out an experiment. The precipitate salt using 0.1 mole per dm cube potassium sulfate. Only 1 drop of potassium sulfate needed to complete the precipitate. 1 drop volume we are assuming here 0.05, and the concentration 1 mole per dm cube. So the mole is 5 into 10 to the power minus 6. And calculate the volume of standard solution required to make it exactly 50 cm cube 0.01 mole per dm cube of potassium sulfate. So we can and do the calculation this way. The moles should be equal. So moles of 0.05 into 10 to the power into 50. This is the mole. Another mole is 0.1 into unknown V. So from here you can calculate volume is 5 cm cube. The mole will be same of this one, concentrated one and dilute one. These two moles are equal. So the unknown you can find out. So 5 cm cube BUT is the best experimental setup. Alternative method, we have diluted concentrated solution to the dilute solution, but here when mass is given you have to prepare the solution. But for this case you have decimal place 1 2 3 4 decimal place, so you won't get the accurate amount by the electronic balance given in the laboratory. 2 to 3 decimal place, so the error for this mass will be higher, less accurate. Another one, the student investigate the following information. Experiment 1, here the enhance experiment 1, if you see, mentioning the pointer, if you see here the negative ion is negative ions are changed and mass are changed, and the minimum amount of anion required decreased. And the experiment 2, positive ions changes, mass positive charge increases and the mass increases. So we want to say the question, the effect of changing of mass of negative ion 0.1, 0.2, 0.3. If we see the diagram here, 0.1, 0.2, 0.3, this is decreasing is the answer. Another question, independent variable in experiment 2. I want to see again here independent variable, the positive ions are changes. This is the independent variable. So another question, the arsenic sulfide. Arsenic sulfide is the soul of negatively charged. Negatively charged. We can remove it by the previous diagram. We need the positively charged particle and the highest positives of aluminum chloride. So aluminum chloride is the answer for this question. Again, I'm mentioning aluminum chloride has the highest positive charge, and arsenic sulfide is the negatively charged particle. So we can use aluminum chloride to remove it. It has the highest charge. Up to this, thank you very much. If you have any question, you can write in the comment or you can call it directly. Thank you very much.